Hello everyone. I will introduce our GUI application. In the first panel, on the very left side, we have experimental protocol and data panel. So we can change the protocol according to your experiment. For example, we can change the step size from 10 to 20 and hit the update button. And once we updated the protocol according to data, now we are ready to import data into the app. So in the bottom panel, click the import data button, and then we can select experimental data. So these files are for each cell, the experimental data from each cell, and each cell contains multiple current traces according to the protocol, the number of voltage steps applied to the cell. I will import this cell. Then now in the figure below, it shows the experimental data, the potassium current recordings, potassium current trace.
And this is IKsum.
That's right.
Under what wattage?
So it's on the last column. It's the last column, so it should be the 50 millivolt.
So we have obtained IKsum currents under 9 clamped wattage. So that's why the first column A is time, and then we have B, C, D, E, F to J. Can you go back to Excel? And those are the 9 IKsum currents under different clamp wattage. The column J is under clamp wattage plus 50 millivolt. And now let's run calibration. So the middle panel is computer model. So here we included KV 4.2, that's IKtoF, that's transient outward K plus current. And we can choose to include or exclude by click on the checkbox. See, it will go away, but definitely this is a major current. We need to include this. And we can also click on the KV 1.5. 1.5 is IKslow 1. 2.1 is IKslow 2. IKSS is non-inactivating steady state potassium current. For each of those individual currents, we can choose to include in the model or exclude in the model. So for example, IKslow 2, we can also click on the checkbox. Yeah, it will, as we can see in the individual currents, that current will be excluded. Now let's check it again to include this. And the same for KV 1.4. Now let's click on run calibration. So if we click on the run calibration, this will show the progress bar, and in the background, the optimization algorithm is running to calibrate the computer model to the IKsum traces we obtained from 9 wattage clamp protocols. In other words, computer model is the same cell. We need to obtain IKsum currents that match the real world data. Blue is experimental data. The red is model prediction. Now you see the default model prediction has vast discrepancy from the experimental data. This blue experimental data is the IKsum current traces we obtained at minus 30 millivolt. Minus 30 is the lower left. Yes, right there.
Yes.
And as you can see, the amplitude is about, the peak is close to 2, right?
Yes.
And we can also change different wattage. So once the calibration is done, as we can see, the minus 30 millivolt is well calibrated. And now let's check other voltage. Can we go from 50 millivolt? So this is 50 millivolt. And then let's go to 40.
40.
And 30. 20. Just go each one of them, please. And we can inspect under each clamp voltage, what is the discrepancy between experimental data and model, calibrated model prediction. As we can see, even under high noise level, we fit the model very well. And once you finish the calibration, you can save the model parameters. As we can see, there is a button over there. You can save it. Now we are going to import experimental data for one cell. That's 1002. And we also import the saved model parameters that are already calibrated.
Mm-hmm.
Import, please. Okay, now let's see the, you see the right-hand side, the file is 15N10002. So that's calibrated model parameter data. Now let's check the calibration under each voltage. Minus 20, minus 10, 0, 10, 20, 30, 40, and 50. In general, if the voltage, like clamp voltage is in very low, under minus 30, for example, if you look at minus 30, you see the amplitude is very low in the experimental data. Can you put your cursor in the experimental data? It's around like 1.4, the peak. And also, if you look at the imported data, 1.4 compared to the high peak we obtained on plus 50 millivolts, that's around like 45 to 50, right? The peak. However, minus 30, the amplitude is very low. It's very noisy. That means we had the data in low voltage, minus 30, the amplitude is lower than, it's much lower than the plus 50 millivolt clamp voltage. But as you can see, the calibration is done very well, and it's fit. Actually, the calibration did a great job fitting into the data for all the 9 clamped voltages. And this is also very helpful for us to obtain the individual currents. As you can see, because we fitted the IKsum, the model also gave us the individual currents. So as you can see in this plot, we have IKtoF, IKslow1, IKslow2, and IKss. And the individual currents are all obtained. And also, if you click on different tabs, we can also get the density voltage relationship. And also KV 4.2, the parameters. So we have it for KV 4.2.
Yes.
KV 1.5 and also KV 1.4. So, but here you have alpha A, beta A. So those are all the parameters that you obtained for different channel kinetics, right?
Right.
Can you show us what is alpha A in the middle panel? So that's alpha A.
That's right.
Under. So when you say x-axis is the voltage, y-axis is alpha A, but alpha A is changing with voltage, right?
That's right.
Okay. So this is the alpha A function of the voltage. For example, this equation alpha A, can you put it in the equation? Alpha A, P7, P5. Once P1, P5, P7 is fixed, they are fixed, then we will be able to obtain a functional curve of alpha A versus the voltage. So that's what the curve represent in the right-hand side. Okay, very good.